Hi everyone, thank you very much for being here today. Phil, you're in the way. We have a few very exciting things to share with you. But before I begin, I'd like to ask each and every one of you a question. We're not at the right slide. There we go. How many times have you been... How many times have you... Hello? How many times have you been trying to... How many times have you been trying to focus when all of a sudden there's a loud noise that gets in the way? I mean, it's really, really frustrating, right? You're at your desk and that... Or there's somebody talking in the background, or your car, there's a motorcycle going by. I mean, noise is actually a pretty big problem. Turns out we actually spend about $600 million every year trying to make our homes and our offices a little more quiet. But there's a problem. There's a really big problem. You see, the current options today are very toxic, they're flammable, they're dirty, they're weak, they're ugly, and they just don't work very well at all. To be blunt, I think they're actually really terrible. So, wouldn't it be great if there were a non-toxic, fireproof, clean, durable, visually attractive solution that actually worked? Well, folks, that's what we've created. Today, I'm excited to present to you a material that could potentially revolutionize the way we deal with noise. Anybody like to, maybe this one's too big to pass around, but you can come over, yeah, go for it. So this material is very unique and it has a lot of very unusual applications. It can be used in your homes or your offices, airplanes, cars. There are a number of very unique applications where a lightweight, moldable, noise-absorbing panel like the one going around the room over there would be very beneficial. Now, you're probably wondering, okay, now this looks really cool, but how do I know that these guys aren't bluffing? I mean, where's the evidence? Well, I want to show you right now a little video about why our material is better than anything on the market today. Are you ready? Let's watch.
Hey everybody, it's Rootbox from MegaMatter, and today we'll be showing a side-by-side comparison of two panels that are available on the market compared to our panel as far as it's concerned with fire testing. Alright, so we're going to light up the first one. It's going. Starting to catch on fire. Alright, there's too much smoke now. We definitely gotta stop. Okay, and now we're going to do the Sonolight panel. Alright, it's going. Oh. Yeah, that one burned up even faster. Alright, and now it's time for our panel. Let's go. Get up and check the back side, see if there's anything on the other side. Nothing. Yeah, I don't think it's going to be going anywhere. I'm just going to shut this off.
Okay, did you have any idea? Did you have any idea how dangerous acoustic panels were? No. Well, now you do. But you see, it gets even better because the product we've created is actually absorbing 44% more noise than any other material on the market today. 44%, that's huge. Here's a graph showing, their laser pointer? I don't know. There's a graph showing our material in the blue and every other material on the market in green. And as you can see, we absolutely destroy every other product. Now, to better illustrate how good our material is, we're going to give a little simulation. So we actually worked with Dr. David Dubink. David, are you in the background here? Well, maybe he's here, maybe not. But Dr. Dubink is an expert in noise reduction technology, and we're going to give a little simulation showing how good our material is. And this is scientific, we're not making it up. Okay, that was a truck normally. Now this is what it would be like if we had our material in front of it. Did everybody hear that? Now we're going to play an alarm. This is what it would be like normally. Okay, now this is what it would be like with our material in front of it. You better be careful with that or you might not even wake up in the morning. Now, here's another graph just to illustrate how good our material is. Again, we're in the blue, and the top competitor, the one we burned up the second time, that's the one in the green. And you can tell we're way better than anything on the market today. And if we were to manufacture the material, we think we could make it for about $3 a square foot. It would go for around $6 to a distributor, and retail would be around $10 a square foot. That's the average cost of an acoustic panel today, and that would give whoever is making it a 100% profit margin, and that's pretty good. But you see, it gets even better, because what we've created actually is a way to turn a piece of foam into a rock. Foam into rock. Now this is a huge scientific achievement. I mean, what we've done is take a process that should take millions of years, and we're doing it in about a month. Now right now, we're focusing on acoustics because we're only getting the outer edges to turn to rock. There we go. See this, that's on the bottom. The part that's circled in red is the rock portion, and everything to the right is foam. But the really cool thing is that we found we can actually do it with any material. So we can make it, see this one's a little different. It's a different substrate, and it's got a very different characteristic than the foam. So that's actually extraordinary that we can take any material, any flexible material, and turn it into a rock. And the applications for that, I'm going to pass it around. And the applications for that are huge, because if we could achieve that, we could literally roll out a driveway or build an entire building out of foam. And when you're ready, you take that foam and turn it into rock. I mean, there's all sorts of things that realistically we can do with a little more time. Now, the incredible thing is, we've done all of that in 3 months in Rootbox Backyard. So I just want you to imagine for a moment what we could do with better equipment and a little more time. So this is probably a good opportunity to introduce our company. We're called MegaMatter, and our goal is to invent, develop, and license the most innovative materials in the world to large corporations. So our target customer would actually be a company like Saint-Gobain, a multinational French material manufacturing company, or 3M, maybe even DuPont or the Army. And the problem with a lot of these institutions is that they have a lot of people working on stuff, but they're too large and bulky and conglomerate-y, I don't know if that's a word, but they're too corporate to innovate at the speed that they need, and that's where we come in. Now, this isn't actually a crazy thing that I'm telling you. We're actually talking with Saint-Gobain right now, and we're negotiating a contract to fireproof a foam that they've created. And we're also talking with 3M about licensing our material for acoustic purposes. And we do expect to have a deal within 3 months with Saint-Gobain. Now, this is our team. My name is Arlen. I studied architecture at Cal Poly, but I love inventing. and I've been running the day-to-day operations of this company. My other co-founder is Rupak Mitra. He's right over there. Rupak is an incredible materials engineer. He's the best. He knows chemistry better than anyone I've ever met. Well, I don't know chem, but Rupak is incredible. I mean, and we work very well together. And Rupak has been able to take the concepts that I've come up with and actually make them work, which is a really great collaboration. And then we recently added Phil. Phil's another material engineer, and Andrea, who's been in charge of our sales and marketing. I'd also like to mention that we have Eric Meyer. Eric here? Yeah, we have Eric in the back, and Eric's been our lead mentor, and very much appreciate the help that Eric has given. So we'd like to thank you, and what questions can we answer? How much time do we have, Jake?
We have a few minutes.
We have a few, okay. We'll begin with the mayor.
Oh, thank you. How do you turn foam into rock? Is it magic, or what do you do?
We kind of go like that. The question was, how do you turn foam into rock? And we can't tell you at the moment, but
No, just in general terms. Like what, no proprietary secrets.
we are
It's pretty proprietary, to be honest. So it's fairly proprietary, to be honest. So I mean, it's basically a pre-processing method and a post-processing method, and we kind of just apply these two. I don't know. Does that make sense? All right.
How much space is required?
Wait, what?
How much space is required?
She asked how much space is required, and actually, we just add so we pre-process it, and that's actually very efficient. And the post-processing is just actually adding our chemical hardener to it. So there actually is no extra added manufacturing or equipment required.
We can do it for very cheap. Yeah, over there.
Does it retain its acoustical properties when it's rock?
Actually, yes, it does. In fact, it actually does better because the gradient of the rock. Actually, I'm gonna let Phil answer this.
The question was, does it retain its material properties when it turns from foam into rock? Acoustical properties.
Yeah, so when it's rock, the density of it goes from like more dense to less dense, and that's actually ideal for acoustics because the more dense something is, it absorbs lower frequencies. So when you have kind of a group of different densities, it absorbs more frequencies than it would normally. So.
Okay.
Yeah.
What are the 2 or 3 end products you're really thinking about far ahead?
The question was, what are the 2 or 3 end products that we're developing right now, or thinking of in the future?
You answer that.
Did everybody hear me when I'm shouting? Okay, great.
Do you ever work at Carnival?
Yeah, I'm normally the guy in the cage. Our MVP is an acoustic, an architectural acoustic product that would go on your wall.
It's actually on the walls in one of the rooms over there. So if you want to check it out.
And our goal really though is just to provide a proof of concept and then allow the manufacturer to go forward with however they want to do it.
Basically, your product is intellectual property.
Correct. Thank you for mentioning that. One important thing I forgot to mention is that we are patent pending with everything we've talked about today.
We can do one more question, and then you guys can continue asking them questions after the presentations.
Yeah.
So when you were showing the simulations, the sound absorbing simulations, can you give some more information on what you're doing? I mean, my sense was, you were showing with no form of sound absorption, and then somehow with your concept, but it's unclear, were you surrounding the listener with it, or what were you doing?
No. So basically what was happening is we took sound files from, so they would play these sound files, and then they were at these certain decibel levels, and it was frequency matched. So by using computer simulations, we basically measured our sound panel absorption at these specific frequencies. And so maybe it'll reduce 23 dB at 1500 hertz, and 500 hertz will reduce 10 dB. So we take these different frequency reductions and we applied that formula to the sound that you're hearing.
So I understand what you're saying, but that's not really taking a true application of it, so to speak, and doing a comparison.
Yeah, it's a model. It's a simulation.
I mean, I understand it's a model, but you're not, for example, you're not like modeling someone being in a room that was, had this paneling around them or just a single wall. You just completely took the de-attenuation over the frequency spectrum. So I guess my point is it's not really a real accurate.
Yeah, no, but basically the formulation and what we did is the same stuff that all the other companies do. Because like you said, if you are in a different room, there are different effects. Like you have the sound bouncing off different ways. You have different feelings like that. But it's basically a straight, just a parallel line.
We love to continue talking with you. We're going to be in the back cubicle over there, and thank you very much.